We're now into example 3 from section 1.3, and this is involving completing the square. Now, provided in the textbook before example 3 is a nice little chart that really explains how completing the square works, and it involves something you may have seen back in section P.3 involving operations of polynomials. When you're multiplying polynomials, realize that this is a multiplication of polynomials. This is like x plus 5 times x plus 5. And this is x minus 3 times x minus 3. Same thing as, so when you square, it's repeated multiplication. So if we were to multiply this out, we would have to use the distributive property, and we would end up simplifying it to this result: x squared plus 10x plus 25. So when you square a binomial, so this is a binomial since there's two terms, and when you square it, you'll end up getting what's called a perfect square trinomial. Now, there's a special feature, a characteristic of a perfect square trinomial that you'll need to notice, and that's it has to do with the x term and the constant term. There's some characteristic between 10x and 25 that you'll want to notice. You'll always notice that if you divide 10, the coefficient of the x term, in this case, so the coefficient of the x term, if you divide that by 2, that's equal to 5. If you take that number that we divided by 2 and square it, we get the constant term right there. And then we'll also see, similarly, that if we take, and you have to take the sign in front of it, including, you have to include the sign in front of it, and you take -6, and we divide that by 2, that's equal to -3. But then we notice that when we square it, it really doesn't matter too much. So we have, so what we divided by 2, similar to what we did up here, if we divide -6 by 2, we get -3, and then we square that number, we end up getting +9. So that's always a feature you'll notice, a characteristic of a perfect square trinomial. And we're going to use that to complete the square, because our objective, ultimately, you'll notice, and I'll point this out in a little bit, is to go from a perfect square trinomial to a square of a binomial. So we're going to go backwards eventually. So we'll see how that works. All right, so looking at this problem, what we want to do is we want to get the x terms on the left side of the equation. So we need to get that 2x onto the left side of the equation. So we'll have x squared, and then we have to subtract 2x to get it on the left side of the equation. And we're going to leave a blank here to fill it in a moment. And we're going to leave the +6 on the right side of the equation. We're leaving it over there. We're just moving the x term to the left side. So we have now what we want on the left side of the equation: x squared minus 2x blank equals 6. All right, now we want to do the completing the square. Now, at this point, we're kind of in this form. And so our objective is to get a perfect square trinomial so we can factor it to a square of a binomial. So right now, essentially, we have these two terms. We have the x squared and the x term. So we have x squared minus 2x. What we want to do is figure out what we need in this blank to get a perfect square trinomial. And we're going to use this technique over here to find that number. So what we notice with the perfect square trinomial, as mentioned before, is if we divide that x term by 2, so in this case, sorry, the coefficient of the x term, if we divide that by 2, so we take the -2, like the 10 and the -6, we take the -2 and we divide it by 2, we get -1. And then we took that result and we squared it, similar to the 5 and the -3, which was the result of dividing by 2. We squared those two numbers. That gives us +1. -1 squared is 1. So if we were to add 1 right here, we would have a perfect square trinomial. Okay, so, but the thing is we can't just add 1 because that changes the entire equation. But the thing is if we add 1 to both sides of the equation, we keep the balance of equality. Because what we do to one side of the equation, we can do to the other side of the equation, and we still have equality. So what we now have is on the left side of the equation, we have a perfect square trinomial. So this can now be factored. Let's just, on the right side of the equation, let's simplify that to 7. Now the left side of the equation, we can factor this to a square of a binomial. So let's see how this factors. There's something you'll always notice, and it's just a shortcut I'll share with you, is notice that the positive 10x, the positive 10, the coefficient of the x term, half of that number is positive 5. And then the negative 6, the coefficient of the x term of this other perfect square trinomial, half of that is negative 3. You see negative 3 here. So you'll notice that this will always factor to parenthesis x, and then notice that you'll have the n parenthesis squared. You just have to fill it in with half of your coefficient from up here. So that's just negative 1. So you have x minus 1 squared equals 7. There we go. We have completed the square. At this point, we just want to finish solving the equation, which we use the technique from the previous slide, because now we have something being squared is equal to 7. So we can take the square root of both sides of the equation or use the square root property and get x minus 1 equals plus or minus the square root of 7. And then we say, now we just subtract or add 1 to both sides of the equation, and this is equal to 1 plus or minus the square root of 7. And so we could express this as two separate solutions. X equals 1 plus root 7 and 1 minus root 7. If you need help with everything we did after this step right here, please look at the previous slide and review that. But yeah, we've already covered this sort of concept in the previous slide. And so we have two different solutions, 1 plus root 7 and 1 minus root 7. All right, let me know if you have any concerns.